So I'm going to talk about IoT. So why do I find this interesting? I've been doing software for some time. First as a developer, then as more in an architect role, and in the last years in kind of a team lead role and in commercial responsibility for some projects. And the thing is, what really kind of stood out in the last years is that there came a realization that, you know, IoT projects are really kind of special in a lot of ways. And really, it's a lot of ways. And what I'm trying to be compressing into the next hour is hopefully a lot of these aspects. So, because more often than not, it's been a struggle for surviving the relative project. And there were basically two major problems apart from all the technology challenges and things that go around, and that is not going broke and delivering something meaningful, hopefully. And but really, what makes IoT so rewarding and special? And for me, it's mostly all of these aspects here. So, you know, I'm from Germany. A lot of our industry kind of is this old-fashioned art of bending metal into things. And our industry is kind of challenged from the rest of the world, where people have been recognizing some years earlier that it's also kind of interesting to make things smarter and maybe not to over-engineer everything to ridiculous amounts. So it is really a thing in Germany to catch up and to keep our industries somehow competitive and relevant in the coming years. And so this, for example, is a picture of, it's probably not, but it should be pumps. And this is one of the projects that we did with a customer, and it helped them to kind of recognize earlier where things are failing and need to be replaced, and things that really mattered, and really they even did it without dedicated sensors. We can make things that we love more convenient, and this is something I love. We can make more free time for ourselves, or make the free times that we have more adventurous. We can help building the infrastructure of our future cities and our countries to be more sustainable and to be more supporting for changing lifestyles. And we can even maybe save some lives. So it's super rewarding, and I really find this to be the case with almost every IoT project that you're touching, is that it's this specific magic when the physical world and digital world comes together and forms something, if it works well, that is just more than the parts of the thing. So I love it. But then, let's come to challenge number one that is kind of strongly connected with that kind of magic. And that is building something and not going broke in the process. So I'm going to talk about the business aspects of IoT a little bit. Selling cake is kind of straightforward, right? So there's a baker, bakes a cake, then people come into the shop, buy the cake, get happy, and as a fair compensation, hand over some money to the baker. Deal done. Everybody profits. It's straightforward. It's not really hard to explain. IoT, on the other side, is getting a little bit more complex. And there's a whole science about this question here, and that is, how does money flow? But really, that's kind of the boring aspect of it. Because that's just the business side. So, I mean, yes, you can sell IoT products for a one-time fee or price and be done with it, or they can be you can do subscription models and licensing, and you can have outcome-based pricing. So, what a what another customer of ours is kind of propagating. They want to stop sell drilling machines, but sell holes. Or you can do some funky stuff around selling data, what the panel before here was discussing. But really, that's not the relevant question when it really comes to the core of the whole transaction or the business. And that is, what is the cake? So what is really the value that is created by connecting things into the Internet of Things? And then, who is the person that gets happier in the process, by using it, by consuming a service? Because that can be quite interesting. So here we go. These are some of the models that people are looking into to kind of define that cake and the people who eat it. Yeah, let's just take a closer look at them. Improve maintenance. Well, that's really a big one, and the order of these slides is going from relatively simple, straightforward, and it works, towards more complex things. So this is really something that has been proven over and over again, and still it is a driver for new businesses using it to really make mostly their lives better. I can use sensors and observation of behavior to kind of detect earlier when a certain piece of machinery is going to develop some problems, some failures. So I don't need to check that often and have people spend their time and maybe flying somewhere to take a look at something if something is still working correctly. If I can as well have a sensor take a look at it. So we get, with lesser inspections and cost that is required to run a certain piece of hardware. We can also prevent failures. Now, is this the same thing? Well, kind of. But failure is something that can be hugely disruptive if, for example, the part that you're monitoring is a critical part of something larger. So you're talking about a production plant that can be more or less shut down if some non-redundant piece of machinery fails. And that is then not only a problem that someone has to come, but it's also, and take a look and repair it, but also that you got the loss of the production of the whole factory for some time. And you want that period of time to be optimally non-existent or as short as possible and as easy as possible to find out what is really going wrong there. And then the people who come on site and are tasked with finding out what is going to happen, they get more information. And that can be quite substantial. For example, if the thing that breaks is an excavator that is somewhere in a mine in Siberia and you don't know what spare parts to take, that's a bummer. And some simple sensors and telemetrics can easily help with that. So that's really some cake. Who profits? The owners and operators. You get less failure, less downtime, less cost of ownership. The manufacturers gain competitive advantages if they can offer these things to the actual users of the equipment. And you can expand your business model from just selling the equipment to also selling services that you then can easily and quite safely promise, because you know that your machinery will tell you when problems come up. And finally, you keep the connection to your customer, and that's also quite relevant, because normally when you're selling a piece of equipment, a machine or just something, well, they take it and they leave, and they might then take a service contract with someone else. If you have a kind of monopoly to the remote access and serviceability of that machine, chances are much better that they're going to stay with you. And when they stay with you, they might remember you when they want to buy their next stuff. So, next would be to track assets. We can use things like GPS and indoor locations and IoT location protocols and connectivity to really kind of detect where things are. And that can go from coarse-grained GPS down to really detecting the location of, for example, construction site equipment within that construction site, and that construction site might be in a tunnel where it's really kind of hard to find things because it's all a mess and dark and dirty. And so what we can do with it is we can prevent loss and theft. Loss might be even the bigger problem, especially when it's outside and dark and messy. People lose chainsaws all the time. And of course, we can do something about theft when, for example, someone steals that excavator. Now, we've had some discussion with that customer about now what should we do if we detect that the excavator has been stolen, because just disabling it is also a very bad idea if that excavator happens to be on a railroad crossing when the theft is detected. So, yeah, so it will not start the next time you try to, and maybe raise an alarm. And you can then try to optimize your supply chains. And that is also extremely relevant when you're moving things through, say, a factory that serves different purposes and has a more flexible layout than the usual shop floor that's optimized for just one thing. Or you can, for example, track the contents of boxes where expensive things that don't react that well to being, dropped from a forklift or be dumped into water, if that doesn't react all that well to it, because then it starts to rust. To find out what is happening to that equipment. So to have some tags on that box while it's being handled, and who will benefit from that? Well, the people who own the things, the suppliers, and a really interesting field of business is for insurances, because when you can sell both the service to kind of prevent the loss or the theft or the damage, when you bundle that up with an insurance policy, it really kind of starts making sense and kind of pays for the IoT solution, while not being while it might not make all that much sense if you do it as a standalone service. All right. Monitor compliance. We can not only track where things are, but also how they are used. And that can also make quite a difference, for example, in the in the life of machines, how they are handled. For example, if I rent out some expensive equipment, or if I'm liable for the warranty of something, I want to see that it's handled in the way that how it should be, because otherwise that can get expensive quite quickly. I can also ensure the safety in dangerous operations. So I can track if things are used in a safe way and then prevent, for example, the activation if it doesn't work. I can use sensors to detect the environmental hazards. Again, equipment on construction sites is oftentimes exposed to toxic, poisonous environments, and you want to know if that starts to leak out. And so you can set up a perimeter of sensors around your construction sites to detect if there's something bad going on with the water or with the air. Also, what is really interesting, and this is the point where it comes to saving lives, is when you've got especially people who might have difficulties in understanding what their medication needs are, or in following them through. So there could be children, there could be elderly people, people with mental problems. it's a huge help to see really are they taking their medications, and that can start with seeing if pills are taken out of a box and tracking that with the smartphones, up to pills that have built-in sensors that can be detected and read out if they've been consumed. And there's a whole lot to be won there as well. So who profits? Well, you can better prove the safe operations of your environmental dangers, of your machinery. The people in charge of regulating things can detect accidents and misconduct, and medical personnel can better see if medication is how medication is used, and then also adjust the medication plans to see that the right level of the medicine is applied to the patient. Make fulfillment easier. Well, yeah. So, who of you knows this infamous Amazon Dash button? Yeah, I know Amazon is not that popular in Bulgaria, and it's probably the most ridiculous thing there is. So you can buy a button from them, a physical one or then virtual ones as smartphone applications, and you glue it, for example, next to your washing machine, and if you're in need of detergent, you press the button, and Amazon will send you a new box. All right, that's the really simple use case for this. It gets more interesting, for example, when what customer of ours is also doing is, so they're a company who's selling industrial tools. And these tools can be hugely expensive. So you have drill bits and machining bits that are encrusted with diamonds, and they only last so long. And you really need to track how long in minutes they've been used, and then see that they are sent back and new one is ordered. And now putting an IoT system into place for taking for tracking the usage and then automating this ordering and regrinding process has been quite an improvement in how well the availability of these tools are for their customers, and also it's very good repetitive business for them. Also, a big one is shipping features by firmware update, and yeah, it's a little bit questionable if this is really an IoT use case, but it is very much connected to a lot of the technology that we use. So you need connectivity, and you need some controller of sensors and actors to make this effective. Now, the most impressive one about this one is something that I heard from a guy being in charge of NASA's space exploration vehicles. And these things have a huge problem because they're shipped up into space with a rocket. And that is kind of dangerous and fails sometimes. And it would be a really a bad thing if you know that in addition to the lost space probe, you would have spent all the effort writing the software for the space probe while it's then exploding into a lot of very small pieces. So what they do is they ship it up into space, they set it on course, and then they write the software. And the only thing that the space probe really needs is working firmware over-the-air update. And this is very much the case with almost every IoT device, right? It doesn't really matter with which feature set you're shipping it and with which features you're developing it or how buggy it is, but you need one thing that really works, and that's firmware over the air. Then there's this whole idea of making things into platforms so that it doesn't really only fulfill your use cases and your features, but can only also be the vehicle where other people can put their own ideas onto. And again, that customer with the tools, they've opened their platform to the manufacturers, so they're traders, but they've opened their platform to the manufacturers of tools that then can provide services to the customers of there, of our customer, the trader, and to so also create this bond between the users, the trader, the provider of the tools, and to really make this a strong ecosystems of connected business relations via providing this platform economy services there. And we can have additional sales channels, for example, by integrating voice services like Amazon Alexa into things that then can be interactive with users and provide them with the opportunity to spend some money. So who's profiting? Well, users of consumables, like the people using very expensive drill bits, can have more available tools and an easy way to get their consumables. Manufacturers and resellers can get a competitive advantage, and you can extend your business to provide platform services and do a lot of interesting things with it. And last, and this is where all this tracking comes in, is so what is really tracking? There's hardly any value in just getting these data points, but what you can use it for is to understand the context of how your devices are used. And you can use that to get information to make it a better product, to see, how is it used, how much are certain features used. Okay, if that feature is really been used a lot, we should maybe make more of that. Or if we see that people are having problems getting a certain workflow executed, then we maybe be thinking about the user experience design and usability of that one. We can gain insights into users' behaviors. Yeah, and well, that's really questionable who will profit from that, because then we get into business models like this indirect usage of user data, and we might even think about selling the data. But then a lot of people try that, and it almost never comes to really. It really almost never goes anywhere when you're not really Facebook or Google or someone as big to leverage that for really building a business onto it. All right, so that was that. Now, anti-patterns. What you also often hear is, hey, we need to do IoT because, well, data is the new oil. We'll just collect the data, and then we'll do whatever this data will enable us to do, because we've got these super smart algorithms. And well, no. What you create is normally then just a big dump of data that really is really hard to understand, and yeah, and it kind of can be an entrance to useful IoT use cases, because if you want to do this, you've got to build devices with sensors and connectivity and some platform to deal with it. But usually those features might be not really in good alignment with actual use cases, and so they even might end up over-engineered, too expensive, and not all that useful as if you were just designing something for a purpose. So building things without a purpose doesn't really pan out all that well. You kind of get that kind of thinking about AI at the moment also a lot. So yeah, so let's just use AI to solve something, and then things are going to be great and useful. Well, no. We need to learn this. So we're building this product because we can't do it, and we need to kind of the way into thinking like an IoT company and a digital company, and so we need to make this first iteration. Yeah, that is not even that bad. But people might think about, maybe not building the full product, but maybe building some prototypes, some smaller things, and not just one, which is an expensive piece of product, but rather 5 smaller ones, and then do smaller iterations and be fast with it and learn from your mistakes. Also, when, I'm at a services company and when people come to us with that approach, it could be a better idea to just maybe hire some experts to guide them, but that they are really in full control of what they are trying to build there, and not give it away and outsource it, because then, who's really doing the learning? So, yeah, I'm really happy to work with clients who have been through the circle, because then they know what they're doing and can better guide you. But if it's just about the learning, then it's probably better that if they do that by themselves. Also good argument, well, our competitor also has IoT, so we need it too. So we want to build the same thing that they have. Yes. The problem is with that approach, so your competitor has come to their solutions for some reasons, and they might not be your reasons. The product might work in a different way, they might have different customers, they might have worked with these customers, or they might have just done it wrong, and now they've got this solution, it looks shiny and nice, but it's not all that good and successful, but they won't tell you. All that you see is that your company kind of falls behind against someone, and then you're repeating it. It's really better to take the approach to understand what, if you want to follow someone, to better understand what have they been solving, and then to take the baby steps in that direction and see where they're going and where it takes you. And it might take you to something completely different, and it might come up with a more suited and easier to build and easier to maintain solution than just trying to copy things. And also, as a service company, I'm not really happy with that reasoning, because, what can you do? You can make the perfect copy, but then people are probably going to be unhappy with the result. And, well, that never really works out in the end for a services company, because unhappy customers, well, I'm not going to like you for the next things they want to build. And then there's also this motivation. We need to show something on the next trade fair. And by the way, it's in a month. So please be quick. And we need the full functioning end-to-end showcase. Probably they don't. But what they do is they either want to project something about themselves to show that they are a modern company and that they can think about and develop this kind of service. So maybe they can just build a demonstrator to have a talking point, or they can build, again, small increments and see how the customers react, and then steer future directions from the feedback that they're getting. Because in the end, these products are all tend to get some complexity, because the business model isn't all that straight and straightforward. So you really want to know, is there going to be really that use case for your customers that they will be happily paying for? All right. Now I want to include you a little bit. This is the pictures that we had before. So this is the railway operator. I'm going to do this one, but I'm going to ask you to step in for the next ones. I don't have a good microphone here, so maybe you can be a little bit loud. So what we see here is an IoT product, and it's about these switches on the railway tracks. In Germany, we have a lot of train delays. And this may come as a surprise, but it's really it's a little bit interesting when people come to Germany and then they're locked up in a train for 2 hours because the air conditioning is not working, which happens a lot in summer. Or when there's huge delays, because there is really, in the whole German railway system, there's about 160 switches, and if and they're all critical. So if one of them fails, you get delays all across the country, because trains start then queuing up and waiting on each other. And so customer of ours, they're a startup, and they are developing a data platform that has devices on those switches that can glean from the vibration of trains going over it, how well that switch is being maintained and how well it functions, and then can raise an alarm when it starts to develop problems so that they can fix it before it becomes a problem. So what's the cake? We improve maintenance. We detect problems with these 160 switches earlier. And who benefits? The whole country benefits, because it's going to have less train delays if the railway system can kind of get these 160 switches to work properly. And that's huge. Also for our provider, for our customer, that's their core business that enables their whole company. So, yeah, you know what? It seems like the animation on those slides isn't working all that well. So there's not too much guesswork here. I'm just, you know, I don't have a working microphone anyway. So yeah, the thing with the pumps, we can also detect health send replacements in earlier. These things tend to be also used not only for water and air, but they're also pumping chemicals. So monitoring the environment can be interesting if you see from the, for example, dropping energy consumption on one of the pumps, that there might be a pressure drop where there shouldn't be one. You can shut down the whole system and raise alarms without any additional monitors and sensors. Also, yeah, our customer can better understand how these pumps are being used and maybe offer replacements or upgrade new models, more powerful pumps, when they see that the load that is put onto them is not really adequate to their design. Yep. Who benefits? Well, a lot of people there. Coffee machines, well, that's something where I'm a little bit of a kind of split mind, because I like really these analog coffee machines where you have to do everything by hand. But then people are also really into convenience and use these pads. You can do this with automatically reordering coffee, especially when it's commercial machines. The bigger ones in cafeterias and restaurants. You can understand your context better, you can improve the maintenance, and for manufacturers this has this huge advantage that they can try to build a vendor lock-in system where people from the standpoint of convenience just tend to buy their coffee from them, and since it's so convenient they might even opt in for some proprietary consumables like these coffee pads rather than just grinding their own coffee, which is of course recommendable. Yeah, we talked about the medicine, the use cases around that. Another thing that we built some 2 years ago solves a problem around tracking assets. In some countries, counterfeit pills and other pharmaceutical products are a huge problem. So when you buy a package of medicine, you really never know if it's genuine or not. And so there's regulations in place now in a lot of countries that demand that that a package of medicine is tracked from production until the point of sales, and you need to have tracking in production, and you know if there's quality problems, then the serial numbers attached to that thing need to be registered with a central database, so they are marked as invalid, so that people are not using invalid serial numbers for counterfeit medicine, and so on. And if you buy then a genuine piece of medicine, you can scan a barcode with your smartphone and it can tell you, yes, this can be traced back into the factory where it was produced. And this solves a huge problem there, that you don't get just sugary pills or maybe things that have some even bad effects on your body. Now here's an interesting one. So how do you turn a Caravan into an IoT device? And we've been consulting with customers of ours that is trying to solve this problem. And they're really struggling hard about that, but I think we kind of got there. So remote diagnostics is a thing. Yes, they wanna know what's going wrong. They want to support new peripherals when you add new apparatus, new fridges, maybe an electric step that will be automatically moved out when you open the door, but it needs to be controlled by something, and your central control unit in that Caravan then needs to be updated, for example, to support these new peripherals. But the really interesting thing there is to understand context, because they build these control units and they build it into the Caravans, and then the Caravans are rented out. That's the normal life cycle of a Caravan. It's first in its first year or 2 years, it's rented out, and then people are buying it. And nobody really knows what's happening with all these Caravans, how people are using it, and how they're using it in rental, and how they're using it in when someone buys it. And for example, that means, how much insulation do I need to put into the thing? So what's the temperature range in which it is used? Do people even use the showers? Nobody knows. And if we knew that, then we could build these Caravans much more to the needs of people, and maybe better hit a price point. But currently, everybody's just guessing, and everybody's doing what the other guy does, and there's zero data about usage of Caravans, and so our customer is trying to solve that. Yeah. Oh no, this piece of animation works great. So really, the main problem with IoT is, and the business model and how to make money, is it is not really clear in some cases what the cake is, who is the end user of things, and who is paying. And that might be drastically different people. So it creates complexity. And now who has to deal with this complexity? It can create conflicts of interest. For example, if you are selling to someone, but then you are really adding features, so adding cost and complexity to the product for the benefit of someone else, and that makes it hard to understand and hard to communicate, and also it creates these conflicts of interest. Now, who do I cater for? Who do I prefer when I have to make decisions about my product? And then there's the problem that these complex business models and insecurities are normally handled by companies who are not really well prepared for that. There's two categories that we often meet. One is startups, and they have a really clear idea about the business model and have all of this really thought through and are quite well equipped with the digital part, but they don't know how to make things. And especially with industrial products, that can be problematic if there's regulatory stuff going on, like if it's pharmaceuticals, and durable machinery can be hard for them. On the other hand, you have these 150 years history companies who are bending metals, and they want to become a digital company, and they got no idea how. So they have problems handling this. Their people are often inexperienced with thinking it all through and following it through. And then also the investments are quite high. And for startups or companies who are treating this as something that is not in their core business, it can create the situation that it's highly risky, it's high stakes because there's a lot of money at stake. Your stakeholders, the people that you talk to, will be highly affected by that, and that leads to really challenging problems. Now, as engineers, how do we do this? We need to understand what's going on there, and that people are nervous around these projects because they might not fully understand what they're dealing with. They're dealing with complexity that they're not used to. And the best that we can do is to be really explicit about it, ask them about it, and kind of share our insights into it. So talk about these things and understand the risks that people are taking, because they might be in situations where they don't want to be, and that they might be in deep water and not that all that relaxed. So understand the problems and keep understanding it while you're building it. Challenge the assumptions. Challenge also the people that you're working for. Make sure that the product that you're building is really fulfilling the idea that it was built for, because with conflicts of interest, this can change over time. So, you wanted to do it for, say, the end users, but then maybe your traders become more interesting while the backlog is developing, and all of a sudden the value that it should be creating diminishes behind another goal. And it's really a good idea to verify your product as often as you can. And this will be one of the things when it comes to delivering, because if you have a risky product where it's not really clear if it gets accepted by the people who will be paying for it, then you better make sure that you know that as early on in the development of the product as you can. Feedback loops are your friend. Okay, so that's the problem of not going broke. Now here comes the problem that we also need to deliver something of value. And the definition of an IoT problem is really, that's just too much going on, too much moving parts. You have mechanics, because without a thing, then, well, that's the definition of a thing. It has mechanical components. There's electronics, embedded software, cloud software. Then to make something of value, you oftentimes need to think about the data that's being generated, how to make sense of it, how to make information. And then user experience becomes a problem because it might not be self-explanatory. And also, the business side is not that easy, so you might want to have some people on board who can tell a thing or two about that. Now that creates some challenges in getting the technology right and kind of to draw this all together. And I brought a colleague here. This is Nicola Yelich. He's not here today, but I recorded a little interview with him about his experience with IoT projects and how to tackle them. His role is as a software architect, so he's got kind of the fortunate task to kind of bind this all together. Let's see if we've got sound.
Yes, Nicola Yelich. I work in Zühlke offices in Belgrade in embedded department. I'm a software architect for embedded devices. Well, it of course differs from project to project. It's by far the easiest when there is I would say a simple IoT device which only does a certain very small subset of the communications with only one endpoint. This is, let's say, the simplest thing to do. But when we have an IoT device which communicates with several different devices on several different channels and with different purposes at the same time, then the architecture actually slowly diverges to something much closer to the enterprise architecture. So we borrowed a lot of lessons and practices from other colleagues in this regard. And in the regard of internal architecture, it's mostly separation that proved to be the best. So in other words, the internal business logic should be as agnostic as possible to the amount and type of communication as possible.
So you're touching on a lot of issues there, and I can imagine one thing, and that is you have enterprise people within the whole system, and you have also the electronics, the mechanics
Yes.
to be working. And how do you coordinate all of that?
Well, again, there are a lot of domains where people do not have to cooperate that much, which is making it easier. But of course, in many aspects, we do have to collaborate. So, for example, just to focus on the communication part, there are many wired and wireless protocols. These needs to be synced up with the mobile guys, with the enterprise guys, with the electronics guys, with the mechanics who need to make this particular antenna either more protected or less protected, and so forth and so forth. So we generally try to gather particular groups of requirements and see who is affected by that, and then just go step by step. Usually the best thing to do is create several prototypes before we actually commit to the final hardware design, so we know that each channel can be used as we wanted it to be used. The only difference from the enterprise development there would be the time frame. Because as in everything in embedded, any hardware revision or any mechanical revision takes at least a few weeks to happen, contrary to the software, which is usually done in a few hours or a few days. So all in all, it's a bit more challenging, but when we have this time frame in mind and when we plan for it, then it's pretty much okay.
All right. Can you tell me a little bit about things where you would say if someone gets into
Whoop. Oh no. I killed it. Let's see if we can jump to where we were. Sorry.
Only difference from the enterprise development there happen contrary to the software, which is usually done in a few hours or a few days. So all in all, it's a bit more challenging, but when we have this time frame in mind and when we plan for it, then it's pretty much okay.
All right. Can you tell me a little bit about things where you would say if someone gets into IoT development for the first time, what is probably gonna go wrong?
What would probably go wrong? Oh, a lot of things, of course. One of the things that, let's say, I personally dislike and I see time and over again is reinventing the square wheel mentality from the IoT project. So it's a clash of two worlds, the standard embedded and the enterprise world, and these two are not always in the alignment, and there may be technologies which are perfectly fine for enterprise software, which are very incompatible with the embedded devices. And I've seen time and again people trying to squeeze in the either protocols or technologies or libraries which they are used to on other projects, but they simply cannot use them. Or on the other hand, people are inventing the entire protocols and ideas from scratch, where more standard embedded or IoT solutions could be used. There are also situations where when we use bare metal or Linux systems that application developers are not that aware of the amount of hardware constraints. So some library may be fine for embedded Linux, but completely too resource hungry for the bare metal, and so on and so on. So it's the actual constraints which must be taken into account. So for a bit bottom up. And then step by step, the list of technologies become more and more apparent. So to put in short, given the fact that each IoT device is a cosmos of its own, anyone who approaches such a project shouldn't put the, let's say, already some sort of solutions in his mind and said, oh, I will solve this that way, I will solve this that way. Start with an open mind, go with what you need to have, and then slowly build up to a complete solution.
Okay. So really, Nicola was touching on two things here specifically that I'd like to stress out a little bit. So systems architecture becomes interesting. Even in a simple project where people tell you, you know, we have this thermometer there and we want it to be displayed on a dashboard. You get a lot of components into place there, so you got the sensor, you may have a gateway, you've got some cloud for connectivity, data analysis, then you have a dashboard. All right, so you just stream the data. Then it turns out, well, we don't have the bandwidth for that. And the connectivity becomes too expensive. If we stay, for example, on 4G, we need to make that more simple. All right, you say, then we can go and put some of the computation onto the gateway and have just some small band connectivity, which becomes more economic from its price point. All good. Yeah, except then some feature on the dashboard demands that you have frequent updates. And you can play that back and forth. And if you do that with changing requirements over the time in your project, it's going to be hugely problematic. So there's a strong tie between architecture and requirements that is somehow counterintuitive when you're used to software, where you can always go and change things quite easily. With IoT devices, small changes in requirements can have huge impact on the system architecture, and you need to know about the implications of what you're doing that are kind of hard to grasp from first glance. And then the teams will be running on different speeds. Your software development will be able to, I don't know, complete every 1 or 2 weeks an increment that ships something useful, and you can visualize it to users. Well, but then it needs a change in the embedded software that kind of feeds this software. And they will, for example, because they have more involved integration tests with devices, they will be on a 4-week sprint. And so they might ship a new version not that often. And then they also need to talk to the device itself with the actors and sensors. And maybe the electronics needs to be changed to integrate with things, and they have a larger release cycle then as well. 3D printing and rapid prototyping can help with speeding this up, but you're going to end up with a team setup where there's just different things running at different speeds. And what has been proving as kind of the way that works compared to a lot of things that don't work is to define integration points and then kind of plan backwards from that, and to let everybody work in their cadence and speed, and to have these integration points where really things come together. And then you try to make the most of it. So you get out, you try to test your increment of your system with the real users, gain insights, get feedback, use that to learn and to go to your customer and to replan for the next iterations, and then also to have a retrospective with the teams and to have a small party, because it's a huge achievement to get something out as a whole system. So, to make successful IoT projects, integrate as possible, as often as possible, verifies idea and results with stakeholders, keep an open mindset, adapt to change, and embrace the complexity that it all brings. Thank you for being here. Thank you for listening.